Hey guys, Coach Sharp back. Jumping back into our videos on this 200-page packet, and this is the video for page 11. So let's just jump right in. All right, number 57, first problem of the 11th page of the packet, as y'all can see up there. So kind of a similar problem we've seen on in the last few pages about these chords being parallel, right? So it's not necessarily asking now which two chords are parallel. It's giving us angle or chord measures, okay? So we still have to take that knowledge that we've learned plus some of our other knowledge about chords to answer this. I'm sorry, let me get my marker cap off. I don't want to cooperate. All right, so it tells me arc, the measure of arc CD is 70 degrees. Okay, so, no, that's not writing like I want it to. This is 70 degrees, okay? So, again, if we remember about the arcs, all the way around the circle is 360, right? So, if I'm starting at C, that's 70. That arc, this arc going all the way around, that arc have to all add up to 360, okay? It does have point O right there, by the way. It did have the point. So, AB, since it goes through the center, is a diameter. So that means this bottom half is half the circle. It's 180 degrees. Hopefully that we remember that, okay? So now that's 70, that's 180. So now I don't know what are AC and what are DB, or BD, if we said it that way. DB or BD doesn't really matter. But again, the key to remember here is what we've kind of seen on a couple problems similar to this in the past couple videos. Again, since those are parallel, again, if I was going straight down, this distance and this distance would be the same, all right? So being the curve of the circle, even though it's a little curved, this distance and this distance are the same. So if we actually measured the actual length of the distance, it would be the same. But they're also going to be the same number of degrees, okay? So basically what I got to do is figure out, you know, how many degrees I've used, how many degrees are left, and then cut that in half so I could split it equally. So I'm going to do 360 minus 70 minus 180. Okay, it's actually going to be 360 minus 250, which is 110. Then divide that by 2, and I'm going to get 55 degrees. So it says, what is arc AC? That one, again, because it said BD, it didn't matter. It is 55. So answer choice 3. Another answer choice 3. Look at that. All right, in the diagram below of triangle ABC, side BC is extended to point D. The measure of angle A is X. The measure of angle B is 2X plus 15. And the measure of angle ACD is 5X plus 5. What is the measure of angle B? So this is, again, we kind of skipped over this a little bit. We actually should have done it in class. We've seen a few problems like this, though. Since we started this, again, this is what we call the exterior angle theorem, okay? Again, if we think about it, okay? Angle A, B, and C all add up to 180 degrees because that's what makes the triangle, right? And then angle C on the inside and then ACD, which is the outside, that's a linear pair. They form this straight line. So this angle and this angle also add up to 180, right? So this angle and this angle add up to 180, A, B, and C add up to 180. So the common angle here is C, okay? So I know C is going to be C. If it's C 60 degrees, it's going to be 60 when I'm adding those two, 60 when I'm adding the triangle. So basically, I get rid of that, and I say angle B and angle D are equal to what's on the outside, okay? ACD. So angle A plus angle B is equal to ACD. So now I just fill it in. The measure of angle A is X plus B, which is 2X plus 15, is equal to ACD, which is 5X plus 5. Again, so now all I gotta do is just do my algebra here, combine like terms. 3X plus 15 is 5X equals 5X plus 5. I'm going to start by doing 3X on both sides, actually, because that'll cancel out. And then I'm also going to do minus 5 to cross it out over here and do it over there as well. gives me 2x equals 10. Not going to show divide by 2. I hope I don't have to. Oh, maybe I need to because I wrote the wrong thing. Oops. Divide by 2, so x is 5. Okay. What is angle B? So again, it says you got to read what's asked for. What is angle B? Not it. What is x? So I got to plug 5 into there. 2 times 5 is 10, plus 15 is 25. So answer choice 3 again. All right. Number 59. When writing a geometric proof, which angle relationship could be used alone to justify that two angles are congruent? So this is, you could think about it being tied into parallel lines with a transversal, but it doesn't necessarily have to be, okay? So again, congruent just means equal. Supplementary, right? Well, all supplementary tells me is that there are two angles that add up to 180. The only way they would be congruent is if they were both 90, but you know, you could have one angle that's 100, one angle that's 80, so it's not necessarily that they're supplementary. Linear pair. Again, we kind of just saw that on the last problem with the exterior angle theorem. Exterior angle theorem. I don't know why I struggle saying that sometimes. Sorry if the camera moved. Two angles that are adjacent and form a straight line. So again, the only way that they would be congruent is if both angles were 90 degrees. But of course, you could have a linear pair where one is 100, one is 80. Adjacent angles. So all it means for adjacent is two angles that are next to each other, okay? It doesn't even have to be where they add up to 180, kind of like 1 and 2 have been, all right? You could have that and that. Those are adjacent. It kind of looks like a right angle. It's not really what I was going for, but you could say like that's 40 and that's 31 or something like that. So those are adjacent, but again, doesn't prove that they're congruent, okay? Vertical angles. That's the only one that does. Again, when two lines cross, could be, you know, related with parallel lines with transversal or whatever. I know those are congruent, and I know those are congruent. So it's going to be answer choice 4. All right, the coordinates of point A are -3a, 4b. Point A prime is the image of the point A reflected over the line y equals x. The coordinates of A prime are what? Well, I actually need to go pull this up. Even though this wasn't something y'all could use on test. And again, I don't know what happened to my digital version of the one I gave y'all, so I'm going to have to pull one up online, so y'all give me a second. Yeah, I was looking up Panera Bread earlier. Rules for geometric transformations. There it is. Transformation cheat sheet. Is this one of the ones I was kind of looking for? All right, there we go. That works. I think it's actually the one I showed on the first test. All right. So reflections over the line y over y equals x. Okay. So all I do, whatever y and x is, I flip them. Okay. Doesn't matter if I have numbers. Doesn't matter if I have what's actually there in the problem. The -3b and 4a or whatever it is. We'll see in a second. All I do is just flip the order, okay? So, I got -3a and 4b. All right. So all I gotta do is flip the 2. 4b, -3a, which is answer choice 1. All right, going down, I think it's the last question on this page. Diagram below, triangle ABC is congruent to triangle XYZ. So kind of same situation as we had last problem on the last page for the last video, right? Even though the triangles are kind of orientated different, they tell us what's congruent, okay? So I'm going to try to draw it like they have, and then we can label it and go from there. All right, so I got A, B, C, X, Y, Z. All right, so I know A and X are congruent, right? So I'm going to mark that. I'm going to mark the angles for right now, and then I'll show it. B and Y are congruent because they're in the same spot. And that means C and Z are congruent. All right? Yeah, I know this triangle looks bigger, but they're supposed to be congruent, just trust me, all right? So, again, when they're orientated a little differently now, you got to kind of be able to picture it, okay? The side that's between angles 1 and 2 is what you could say that those are going to be congruent. Or, again, if you go across, which is what I'm going to do, the side across from here gets the 1 mark. The side across from here gets the 1 mark. So those are congruent, okay? The side across from here gets my 2. The side across from there gets my 2. And then the side across from here gets my 3. Again, I have a hard time fitting that in, but my 3 go right there, okay? So which statement must be true? What is congruent to each other? Angle C is congruent to angle Y. Oh, I got 3 congruency arcs there, 2 there. Nope. Angle A is congruent to angle X. I believe it's that one. 1 congruency arc there, 1 congruency arc there. There we go. Let's check the other ones just to be safe. AC is congruent to YZ. AC has my 2 congruency lines. YZ has 1, so those are not. CB is congruent to XZ. CB has 1 congruency line. XZ has 2, so those are not. So does answer choice 2. Angle A is congruent to angle X. All right, there we go for page 11. And I will be back with page 12, and then we'll be all caught up on last week, the 20th through the 24th.